Hello and welcome to another one of D's ADD videos. Today we're going to be looking at this problem here and trying to use the concept of integration by parts to solve it. So in this problem, again, before you jump into a integration by parts, you should always try u substitution. But typically if there's one e, you usually let u equal the exponent, and the derivative of the exponent should be what's in front of you. So here, if you let u equal the exponent, the derivative of 3x is not x squared, so you cannot do u substitution as a result. Next, we try integration by parts. So we got to go through the same routine as we did on the previous problem, and we assign our u and du. Right? So our u and du are off the basis of I late, and if you remember, I late is going to have e at the very end, so u hates being an exponential. It literally will take anything else over an exponential. So if you let the algebraic term equal your u, then your exponential term has to be your dv. And I technically did forget dx, so let's just write it in there. Now we derive u to get du. Derivative, you bring down, you subtract 1. Make sure you keep track of when you have to derive and when you have to integrate. Don't just be on automatic. Be aware of what you're doing. And then here from dv to v, we integrate. So if you remember the rule, e number variable to the first power is e number variable to the first power over that number. You're essentially doing a u sub without doing the work there. It's a shortcut rule. Here is the IVP formula again. U, v minus integral v du, formula your greater than sign that I explained in the previous video. When you plug and chug, x squared times e to the 3x over 3 is your uv. And then you're left with v du. I don't know why I'm not writing dx's in today. This simplifies into giving you your... Now at this point what you can do is you can bring out your constant of 2/3, and then you'll notice that the derivative of 3x is not x, so we have to do by parts again. We already know that u hates exponential, so that's your dv, and use your algebraic. Next step is to derive and integrate. Derivative of x is 1, dx. Oh, I remember dx that time. And then integrate e number u over number. When we plug into the second round, don't forget there's a negative 2/3 constant in front, and this part comes down as part of your problem. It's part of your answer, actually. So negative 2/3 times the answer to this integral is going to be uv minus integral of v du. So uv integral of v du. Now we got to integrate that. Before we do that, we can bring out the constant. So if we bring out the constant, we're left with just e to the 3x. So it's just another e to the 3x over 3 right there that we're going to get one more time. So you can see why it would be annoying to do u sub for this little rule each time over and over and over again. We had to do it like 4 times in this problem. So here when we integrate it, there's the over 3, the new over 3. This is the negative 1/3 from the constant. So then what you can do is 3 times 3 is 9. And then after you do that, let's distribute the negative 2/3 through there. And then you get this wonderful answer there. Okay? Now, if you notice that the derivative of your u term will eventually go to 0, you can do what's called the tabular method. And it's a lot easier and a lot quicker. And I'm just going to do this really fast. You can practice this on your own if you want. So with the tabular method, we're looking at the problem of x squared e to the 3x dx. And we notice that your u term was x squared. And eventually that will derive to 0. So what you do is you put another column for your dv's, and you integrate till you get to that same level of 0. Okay, so then I go diagonal 1 down and multiply them. The first term's plus, the second term's minus, and you alternate. And that's going to be the answer that I should have here. And it's a lot quicker. You can see it's a lot quicker. Let's see if it is indeed the same answer. If I did it here, I'd get x squared e to the 3x over 3 minus, because of this right here, 2x times that. And we see that it does indeed look just like the way we did it that took 10 minutes or 5 minutes. We did it in under 2 minutes this way. And of course this is a definite integral, so we wouldn't forget our plus c. Again, our clue was that the u term eventually derived to 0. You take your u equals, you keep deriving it until you get to 0, integrate the same number of times, diagonal, plus minus plus minus. That's basically it for the intermediate integration by parts. You can see they get interesting. The advanced video will be a lot more challenging. It's something that unless you're aware of the trick, you won't be able to do, and they usually give the trick ones on the exam. So make sure you check it out, and more importantly, practice, practice, practice. Thanks for watching. You have a great day.